Okay. Up until now, for the most part, we have used only SOHCAHTOA trig. In grade 10, we drew triangles with 90 degrees, and we did SOHCAHTOA. In grade 11, we recognized that those triangles may indeed form angles that are beyond 90. But the trig we did was still with the reference angles, which were in triangles, which were inside right angle triangles. Yes? All right. So, trig ratios are only usable for right triangles. Now, if we can make a right triangle, we can do SOHCAHTOA. Yeah? Yeah. So, everybody over on this side, draw a triangle. Label that triangle properly. How do you label a triangle properly? What goes on the corners? Capital letters or lowercase letters? Capital letters. And of course, what goes on the sides? Lowercase letters. And how would we label this? What would go here? Oh wait, my little highlighter dot is not lit up. I hate it when my highlighter dot is not lit up. Please allow me to light up my highlighter dot. What, huh, who, what, why, how, there it is. Highlighter dot is back. What would we make this side? Lil C. What would we make this side? Lil A. What would we make this side? Lil B. All right, now, do you see any 90-degree angles in that triangle? No, of course not. Why? How do you know there's no 90-degree triangles in that corner? Because somebody always says, well, B looks like it might be 90 degrees. There's no little square in it. So none of those 90 degrees. So right now we cannot do trig, can we? Right? There's a duck in the back of the room. And it's not happy. It was funny because it was right after it said, we cannot do trig. Sorry, duck. Have no fear, duck. You will learn how to do trig with this right now. So, I need a right angle to do trig, yes? Everyone agrees, right? No right angles in here, yes? Okay. How could I make this have a right angle triangle, or have right angle triangles? Mandarin, you could cut it in half, yes? All right. Let us do that. We will cut it in half. Boom. Now, stop for a moment. Is that the only way I could have cut it in half? First of all, is it cut in half? No. Don't make that mistake. So we are not cutting it in half, but we are drawing a line, yes? That line has what quality when I compare it to this line? How does the red line I just drew compare to the highlighted yellow line? It is perpendicular. Everybody agree? So I'll ask again, and I will take away that fake word, is that the only line we could draw that is perpendicular to a side that would give me right angles? No, of course not. Madison, where could I draw another one? I could draw this one, couldn't I? Now that doesn't look like 90 degrees. That's just because my hands are shaky. Right? Could I draw this one? Yes. Okay. We are going to use the red one because it gives me the most amount of room to work. Yes? Now that line has a special name. All right? That line is what we call is what we call an altitude. And it goes from any corner of the triangle across the triangle to the opposite side and meets that opposite side at 90 degrees. Now, need it be a triangle? Like, what if I gave you this shape? A trapezoid. And I drew this line straight there. Is that an altitude still? Yes, because it went to the opposite side. Everybody cool? But of course, we're dealing with triangles, so we're going to speak in terms of triangles, yes? All right. Now, that altitude, whenever you see it written in a textbook, for some strange reason, the textbook calls that altitude the height of the triangle. And they abbreviate it with what letter? H. Why is that idiotic? Don't we already use... Oh, Preston, go.
I was just going to say that, like, if you flip the triangle over, then another side can be taller.
Yeah, if you flip the triangle over, it might not necessarily be the height. That is one problem. The other problem is if you abbreviate it as H, don't we already have H in play? The hypotenuse is H, isn't it? So I don't like to call it H. All right? I choose a letter that we never, ever, 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 ever use. I call altitudes Q. Because we don't use it for anything. I don't care what you call it. You can call it anything but late for dinner. Get it? No? All right. Are we all cool? Okay. Now, this is the sine law. Since it's a law, it always works. But as always, I like to show you how these things come about. So let's do that, shall we? If I was only looking at this triangle, can we do some trig with it? We can, can't we? Because it's 90 degrees, yes? All right. Since we are dealing with the sine law, let us do something with sine, okay? So, looking at A, what do you know about A? We know something about A, do we not? What's the sign? Always. What's sine? Opposite over hypotenuse. What right now in this green triangle is opposite to A? Q. Excellent. And what is Q over? C. Everybody agree? Everybody cool? Okay. Now look in this blue triangle. What can we do with the blue triangle? Sine of C equals what? Q over little a. Is everybody cool? Yeah? Excellent. Now, what part of everything we've written there isn't really part of the triangle? Q, right? So let's have a look at Q, shall we? If I want to look at just Q in this black stuff here, how would I do that? I would isolate Q. So how would I do that? You would multiply this by C, and then what? This side by C. Agreed? And we would get to this point. Q would equal sine A times C. Does everyone agree? Everyone sees what we've done? Spectacular. Now, what happens right here? What does Q equal here? sine C times A. Now, you are very intelligent young people. If Q equals that and Q equals that, what do I know about these two? They are equal. So, sine A must equal, sine A times C must equal sine C times A. Everyone agree? Everyone agree? Okay. Now, math people like us could stop right now. Because right now we have now done the sine law. But math people, as you well know, like things to be pretty, elegant, easy to follow. So the fact that this A is with this C bothers them. So they don't like that. So they want to get rid of this times C. So what do? They divide by little c. Right? Now if they divide one side by little c, what do they got to do to the other side? Same thing. They don't like this A being with this C, so what do? Divide that side by A, and then what do they got to do over here? Divide by A. Now I see A on the top and A on the bottom. What happens? Gone. I see C on the top and C on the bottom. What happens? Gone. And now I get a lovely and elegant sine A over A equals sine C over C. Now, you are intelligent young people. If two of the angles and sides share that relationship in a triangle, then mustn't the third side share it as well? That is where we get sine B over B. Now, you will notice it is written this way here, and it is written this way here. Is there any difference? Is there any difference? No, of course not. Everybody cool? This is the way I learned the sine law. For some strange reason, it became sexy to draw or write it this way in the 25 years since I learned the sine law. They decided to put the sides in the numerator instead of the denominator. Okay? So, the only thing that would have been different here is we would have divided by sine A here, and sine C. The signs would have changed places. Right? All right. Now, please notice that this value is a sine value. It's not a fraction. Or is it a fraction? If I put numbers here, for example, if I told you C was 15 and Q was 12, then what would sine be? What would the sine of A be? Damn it. What is the sine of A if I put those numbers there? 12 over 15, right? Which would be a decimal, yes? Which would be 4/5, yes? Which would be 0.8, yes? Now, sometimes the decimal's easy to get, like we just did in our head, yeah? But if it isn't easy to get, how do we get the value that goes there? What gives me the number that I can do math with there? Where do we find it? If I told you A was 47 degrees, how would you get something there that you could do math with? Sine 47 from your calculator, right? Everybody cool? And then that's just going to be a decimal, right? Then I'm going to have a number over a number and a number over a number and a number over a number. Is everybody good? Okay. Let's look at this very first one. In triangle ABC. Now, too many of you get bogged down in the math. Because you're like, oh, the triangle, I don't know what it looks like. Does it matter what it looks like? No, just draw a triangle. Everybody cool? Because we are only using this triangle for reference. all right? It's not the actual triangle. Now all you got to do is fill in your information, right? Angle A is 40. Where is angle A? Wherever you want it to be. It does not matter. Everybody label one of these corners. Everybody label one of these vertices with the letter A. Now you have a 33% chance that you're going to name your A the same place I put my A. I'm going to wait. Everybody done it? Is my A go? No. Hey, how many people got it? Nobody? Nobody put A down there? Oh, heartbreak. Is it going to matter? How many of you are already erasing your A and changing it to over here? Of course you are. All right. Hey, Sam, want to bet your pen that it doesn't matter? Sam, I'm giving you a chance to win back your pen. Have we not met?
I don't need your pity bet.
Okay. All right. I've used it thrice today already. All right. Where could I put B? Now you got a 50-50 chance. Everybody ready? Everybody put your B in. Oh, where she stops, nobody knows. B. Hey! Which makes this side what? Q. C. All right. Now, what do I know about angle A? It's 40 degrees. What do I know about angle B? 75 degrees. Do I automatically know angle C? We kind of do if you guys could subtract in your heads, but you can't. So you get out your calculator and you tell me that angle C is what? 60. 60? 65. Okay, Preston. That makes it okay. Sorry, Iran, we accidentally killed your general. My bad. That's not really true, but I do love how the commander-in-chief down there said, well, we better get rid of this guy. And then did something all by himself and then said, hey, NATO should come and help us. But that's okay. That's like saying, you throw a house wrecker party and you invite all your friends, but you don't invite one friend, and then you call that one friend to say, come over and help me clean up so my parents don't kick my ass. All right. What else do we know on this triangle? AB is what? 6 centimeters. Now, I want you to... Oh, sorry. Thank you. 6 centimeters. I want you to tell me the other two sides. Now, you're intelligent young people. You already know that the sine law says... Now, sometimes I'm going to write the sine law the way I was taught it. And then one of you is going to say, we don't get it that way. And then I'll change to the way that I've written it on here. But it doesn't matter. Okay? I'm going to remember it. I'm going to try to write it because it's the first day. A over sine A equals B over sine B equals C over sine C. Now, before I do anything, I should label these sides, shouldn't I? What is this side? I've called it AB, but that's not what it is in the sine law. What is it in the sine law? Lil C, which makes this what? Lil B, which makes this what? Lil A. Why won't you say Lil? It's hurtful. It's Lil, like Lil Wayne. I found this little note that somebody had written here. Lil. According to Kanye, one good girl is worth 1,000 bitches. And according to Lil Wayne, bitches come a dime a dozen. Therefore, the question becomes, how much is one good girl worth? I would add a corollary question to this. How long before you decide that both Conway and Lil Wayne are human rectums? Kanye. Sorry. How long before... That ruined my joke because I screwed that up. But that would be my B question here. How long will it take to decide that these two are raging a-holes? Less time than it will take to work it out. Back to math. Well, what do I care? I'm annoyed that I even read them. And I wasted any amount of my precious few remaining years spent contemplating either the idiot that is Kanye West or the bigger idiot that is Lil Wayne. And see, I'm already losing more of my precious time to discuss these morons. I have to stop, but I can't. It's like driving by a railroad crash. You gotta look. You don't want to, but you got to. It's like clickbait. When you see that headline that says you're not going to believe what this celebrity looks like 20 years later, you click it. You don't want to, but you do. I know, and then it's a page per person. Yeah, I know. And you can't stop yourself. All right. So, what do I write here? Lil A over the sine of what? 40 equals. What do I write here? Lil B over the sine of what? 75 equals. What do I write here? 6 over sine 65. Now, all you got to do is solve. Right here, you see fraction equals fraction. So what do we do to solve it? Cross multiply. Sine 65 times b equals 6 times sine 75. Right? Now, b equals 6 sine 75 divided by sine 65. Once you've done this once or twice, you start to see the pattern, and you don't necessarily need to write it out. All you got to do that on your calculator is punch it in how you see it. Unless you have a backwards calculator. But I don't think any of you are still rocking the backwards calculator. Unless you don't have a calculator here and you're using your phone. So all we do is punch that in. 6 sine 75 divided by sine 65. 65 equals 6.4. Now, stop. Is that the answer? Yeah. Is it the answer we're going to write down? That's, well, I wanted to know the side lengths of AC and BC, right? So is that one of the answers? You're right, Pri. I understand what you're saying now. Right. Is that the answer? No. Is it part of the answer? Yes. We technically, that is the whole answer, yes? But we're not going to write that all up. We're going to round it off to what? Right? Now, stop for a second. Your calculator has this. You've rounded it off to 6.4. What do I need to do over here? Same thing, yes? Cross multiply. So 6.4 times sine 40 is going to equal sine 75 times a. Get rid of the sine 75 divided by sine 75. Now, I already have that answer on my calculator, right? You guys never want to show work. You would clear this and go back and start from scratch. Don't. Because now all I need to do is I've got it right there. Times sine 40 divided by what? Sine 75. To get 4.25. Now what are we going to round that off to? 4.3. Right? Everybody cool? Why not? Which part? You understand how we got 6.4, right? We punched that into our calculator, so we wrote it there. Then we have that answer sitting on our calculator right here. So we wrote out, we had to do 6.4 times sine 40 now, because we've got to go over this way. So there's my 6.4 answer times sine 40 divided by sine 75, which I did right here. Yes, McKenna?
How come for the work you did in the darker blue, it's 6 sine 75 divided by sine 65, but in the other blue, it's divided by sine 75?
Because I'm isolating this way now. I'm over here.
Well, like you're dividing it by the same thing to isolate it, but on the other one you're not doing that.
Sine 40. I'm not sure what you're asking. The first one in pink, we had to isolate b. So it was 6 times sine 75, multiply the pair, divide the spare. Right? Then over here, 6.4 times sine 40 divided by the leftover one, which is sine 75, because we're working on this side. Now, could I have taken this and moved it over here and used sine 65? Yes, I could have done that. Okay? Everybody cool? Now, we need to check our work. This was 6.4. This was 4.3. Now we check. The largest side has to be across from which angle? The largest angle. Is it? Is the smallest side across from the smallest angle? Yes. Is the middle one across from the middle angle? Are 65 and 75 close in angle? Size? Yes. So their sides should be close in length, shouldn't they? Are they? Is 6 close to 6.4? So are we happy with our work? Yes. So, this, let's do the second one. What does solve the triangle mean? Who remembers that from back in the day? Get everything means get all sides and angles. So we got to draw it, yeah? Doesn't matter what we draw. At this point, no. Well, it has to be a triangle, wise ass. Where do I put D? Wherever you want. I'm going to make it easy on all of you because I know all you want to put D right there. McKenna just thanked me, so obviously I was right there. This isn't my first rodeo, Crystal. I've taught this lesson quite a few times. All right, so if that's D, what's its value? 35. Now, do E and F matter? Does it matter where I put E and F? No, absolutely not. Everybody put it in there. What's it going to be, McKenna? Where's E going? You're putting it at the top? All right, we're going to go with McKenna. All right, now, speaking of Lil Wayne and Kanye, that's a deaf triangle. All right. I'm sad that rap guys don't use the word deaf anymore. D-E-F. Like, huh?
I can't hear you.
That is missing from rap too. All right. What else do we know about this triangle right now? We know two of the side lengths. Yes, which two do we know? Lil E, which is what? 12. And Lil D, which is where? Right or left right now? Right. Now, I need all the rest of the information, yes? Okay. Well, to use the sine law, I need an angle and its opposite. Do I have that right now? Where? D and Lil D. So this time I'll reverse, or no, I'll just keep going the way it's written here. 7 over sine 35 equals what? 12 over sine E. Now, is this the same algebra we need to do as the previous question? Yeah, it's multiply the pair, divide the spare, yes? But we are going to be left with what? Well, let's check on our calculator. 12 sine 35 divided by 7 equals, because that's what we would need to do, yes? Everyone agrees? Okay, so let's do that. Turn my calculator on, clear it off, stop it, piece of garbage, stop. 12 sine 35 divided by 7. Is that an angle? Thank you, Preston. That equals sine E. Is the decimal, isn't it? 0.983. Do I want sine E or do I want E? I want E. So I must now shift sine 0.983. Now, could I do this in one step? Let's check. First, we're going to shift sine our answer. And we're going to keep using that answer key because it's such a good friend of ours. And we are going to find that it is 80 degrees. All right? Everyone agree? So E is 80 degrees. Now, I look at this question. I know that I'm going to be left with a sine, yes? So what I'm going to do is I'm going to go shift sine. Then I'm going to put this in. Bracket 12 sine 70. It wasn't 75, sorry. 35. Close brackets. Divided by 7. Close brackets again. And I can get it all in one step. Is there any mathematical benefit from doing it all in one step? No, because we ended up with the same answer. It's only a time thing. Right? Jocelyn?
I don't understand why you did shift sign after. Why did we do shift sign?
Because I ended up with the decimal. I got the sine, which is the decimal, which is the value of opposite divided by hypotenuse. Yeah. Right? I don't want that. Sine of E isn't anything to do with the size of the angle. Okay? We had little e, we didn't have big E. Right? Now that I know these two angles, Preston is going to automatically tell us what F is, isn't he? And it is 100%? Final answer 65? Yes. Now, can we now find Lil F? How? Should I use 80 and 12, or should I use 35 and 7? You could use Pythagoras if we got a Q, we could then do Pythagoras. But that's another extra step. Should I use 80 and 12 or should I use 35 and 7? I should use 35 and 7. Why? Because it's what we had. It was exact. Because 80 isn't the real answer, is it? What was it really? It was 79.5, yeah? Now, if you're going to leave it on your calculator, go ahead and use 79.5. Right? But if you're going to clear your calculator, I would use 35 and 7. But it's up to you, yeah? Because you know we're going to round off to the nearest or the nearest tenth anyway, right? So, it'll be fine. So how do I write this out? What should I write first? What goes in the numerator when I am working with the last thing I need? Is your hand up, Satjot, or are you just pointing at the ceiling? Okay. What goes in the numerator here? What's the last thing I need to find, ladies and gentlemen? Little f over what? Sine 65 equals what? You could do 12 over sine 80, which is technically 79.5, if it's sitting on your calculator. But I would use 7 and sine 35, because those have been given to me and they're exact. Everybody cool? Now, what is this one going to look like? What is the math I'm actually doing? What should I write here? 7 sine 65 sine 35. Now, am I seeking an angle or a side here? A side. So just like in SOHCAHTOA, when I'm seeking a side, will I ever hit shift sign? No. Shift sign finds what? Angles. Regular sign finds sides. And that is going to equal what? You're going to punch that in and get me an answer. What is it? So 11.1, because we'd round that up. Yes? I don't want to have to do a rounding up lesson. So this is 11.1. Now, do I check? Is the biggest angle across from the opposite the biggest side? Is the smallest angle opposite the smallest side? Yes. Is everybody good? Now listen and listen to me carefully. This is mostly true. But remember how I told you there was a wrinkle with sine law? That's coming up. But I'm not going to do it until Monday. Aight? So turn the page over. Now you will notice this is weird. I've got the work in between the easy stuff and the wrinkle. All right? So this work deals with both the easy stuff and the wrinkle. So you're not going to do all of this right now because some of this deals with the wrinkle. So your job today is 1, 2, and of course it's not just today. This is what I expect done by Monday. 3, 4, 5. You are not going to do 6 yet. You are going to do 7. And then you're going to do 2 of the word problems on page 109. I do not care which 2. 2 word problems. Of course, I'm going to show you all of them. Well, I'll end up showing you all of them. And that'll do for right now. All right? I'm giving you 30 minutes. That is more than enough time to have this finished and take home no homework for your snowy weekend. Because you people are lucky. You live in a city with hills. You could go tobogganing. I cannot. Sure it is. Especially since it's supposed to get really, really cold overnight tonight. It's supposed to melt a little, then get really cold overnight. So all this should freeze solid. And then tomorrow Sunday it's supposed to snow again. So hopefully we'll get a bunch of snow on top of frozen snow, and that is sled in heaven. It's driving hell, but it's sled in heaven. That's because people don't actually know how to drive. Are you all right? Okay, because you were a little funky going out there. Okay. I'm not trying to embarrass you, Rajveer, but 2 years ago, some girl died back there. Or 3 years ago, the year of the stabbing. The first day of the second semester, some girl was standing where Zach was, and I looked and I saw her. Then I looked away and I looked back, and she was sitting down leaning against the back wall. Then I looked away and I looked back, and she was dead on the ground. Now, she didn't die, but it was very frightening. That's why I'm checking. It is not to embarrass you. What? No. But we had to have the ambulance here and everything. But I am so cool that nobody knew anything happened. I know you didn't, because I do not go, ah! I called the office. Please call an ambulance. Send it to my classroom right now. Everybody get out of the way. Mr. Grell was walking by. Mr. Grell, please take my class downstairs. Ambulance came in, took the person away. Nobody knew. Don't know. Didn't ask. But that person was so hardcore, they were back at school the next day. All right.